into the topics and pick some sample questions which already has been they have been solved, just for you to get the concept that this is how the structures of the questions might look like at any point. Sorry, I don't know why my slide is. So this is the equation of equilibrium. You already know it. So from an equilibrium equation, E of f of x, summation of f of x is equals to 0. Summation of f of y is equals to 0. Right? So, and then the summation of what? Of the moment about any point is equals to 0. So when you want to solve the equation that is involving equilibrium, whether it is equilibrium of particles or of rigid bodies, the first thing you need to do is to draw the free body diagram. It's very, very important. Free body diagram is necessary to solve. So if you want, so an equilibrium equation is what? Summation of f of x, summation of f of y, and summation of moment. The other thing that is important is that when you are given a structure or a beam, you have to know the type of the supports. Each support will provide or will produce a different type of reaction. So you have to know the supports, the numbers of reaction they produce, and the numbers of unknown. For example, if I go here, look at this, what we call a cable. So the reaction will just be in form of this, and then it is only one unknown. So when you say the numbers of unknown, we mean how many unknowns of the reactions. It's just one. Here is a link. Also, the link has only what? It has only one unknown reaction. Here we have ruler. This is also a ruler. Number 4, number 3, and number 6. Both of them are what? They are ruler. So what happened? The reaction is always normal. It's normal to the what? To the surface of the roller. A roller is like a cylinder or a wheel. So as you can see here in number 6. So look at the reaction. The reaction is directly on the surface that is in contact with what? With the roller. So the reaction will be directed as such. This is what we call the rocker or the smooth surface. The rocker or the smooth surface, look at the reaction. Also, it is just one unknown. Here, the same thing. When you have a smooth contacting surface, the reaction will be at the point of contact. So, and then it's also one unknown. So these are the types of this thing. But when you have a fixed support, look at this one, number 10. You have what? You have a reaction in the X and reaction in the Y, and you have moment. So you have 3 unknowns. That is why it's called 3 unknowns. F of Y, F of X, and the moment. So the reaction are the couple moment and the 2 forces component, or the couple moment and so these are the reaction. Here you have what? 2 unknown. 1 reaction and then a moment. Here when you have what? When you have a smooth pin or a hinge joint, so you are going to have two what? 2 unknowns. There is no moment here. There is no moment here. So look at the difference between number 8 and number 10. So here you have 2 reactions, but you have no moment. Here you have 2 reactions for a fixed support, and you have a moment. So for you to be able to solve when you are given a structure or a beam, so you have to know the type. It might be stated there the type of what. It will be stated, or it may be stated the type of support. So you have to find the reactions. You have to put the reaction there. So these are type of beam. So when you have this type of beam, when you have a beam like this, we call it what? A simple beam. Where here you have what? You have the hinge support and what? The ball support. So what will be the reaction of this? The reaction of this will just be a single arrow. That is what? That is normal to this surface. This one will be an arrow in X and an arrow in Y. So if there is A here, this become AX, AY. If there is B here, this is BY. There is no X here. So this is what we call a cantilever. A cantilever is supported at one end that is fixed. So you are going to have what? X, Y, and moment. X, Y, and a moment. Because this guy is trying to rotate it. So there must be a counter moment here. So this guy is like here. So this is a fixed, this is what we just seen. So number 10 is like this, cantilever. Here, this is what? A combination where the ball is here and what? The hinge support is here. So X, Y, and Y also. So these are the type of end support. This is a cantilever that is supported. So this one is called simple supported beam. This is this cantilever supported beam. If it is not supported here, it's just a cantilever. If it is supported here, then it becomes cantilever supported beam. So when you have a beam, for example, you have a beam like this, and then you can see the force 4 kilonewton. This force can be more than one. This force can be more than one. For example, what I'm trying to say, you can have assuming I can introduce another force here. So just wait, let me insert. So So, for example, I can also decide to introduce maybe another force here. This is just a demonstration. So what I'm saying, so when you see a beam, it does not mean that it's only going to be only one load. It can be more than one. So this is this type of load is called what? This is a concentrated load or point load. We call this concentrated or point load. So if you are asked to find the reactions of this beam, so the reaction at this beam, so you have to see what type of support here. The support here is what? This is a hinge support. So you are going to have X and Y. So here is a smooth support. So you are going to have the reaction is going to be normal to this surface. That is why we have this NB. Then you now apply your equation of equilibrium. So which always we say that you should take it at the point where you have more unknowns. So we have two unknown here, AX and AY, and then we have NB here. So what we need to do, this guy is not complete. We're supposed to have also, when you draw the free body diagram, we're supposed to have something here. Control C. So we're supposed to have something here. So for the force here is supposed to be here also. So we just introduced this one, so I'm not putting it here. If it has been there, I'll put it here because of the equation here. So here, what you are going to do, you find what? You can decide to write this equation first, these two equations first, then before you apply this. Or you can start with this. So you say the summation of moment at what? At A. So it will be what? It will be, so automatically you are going to cancel here. Then here you are going to have what? You are going to have NB. So you have to make this one, you have to take what? The component of this, because this one is at an angle, so you have to take it at what? At X and Y. So when you make it to be what? To be vertical, the vertical component is going to be NB cos 30. As you know, NB cos 30 multiplied by the distance from here to here, because you are taking moment about this point. So it's going to be NB cos 38. Then the other force that is here is this guy, which is 4 kilonewton, 6 meters. It's equals to 0, because we say that is the condition for equilibrium. Now, here, what of the horizontal component? The horizontal component is going to be NB sine 30, but because it is passing through this point, it is passing through before, so you cannot. It's not going to have any moment. The moment of the horizontal component is going to be 0. So this is the only equation you have. So by the time you do this equation, you are going to have NB is equals to 3.46 kilonewton. Then you now write your equation of equilibrium for the forces. This is for the moment. It's going to be summation of f of x, and then it's going to be ax, which is this guy, and this guy is going to be minus, which you already what? NB, you already found it to be what? 3.46 is going to be what? It's going to be, in x, is going to be what? Sine 30, right? Sine 30 pointing to the left. So remember that you always are going to orientate your what? Your XY axis. So the way, depending on the way you are oriented, as we have seen here, this direction of our X, this direction of our Y. So this guy is going to be negative. That is why you have negative A. It's equals to 0. By the time you do the mass, you have AX is equals to 1.73. AY is equals to 1 kilonewton. This is how to determine the reactions of beams. So this is again the same thing where you have more numbers of forces. So what you need to do is to find what? The summation. Also, initially you draw what? Your free body diagram. Your free body diagram is here. Look at here. We're having only AY. Why are you having only Y? Because this is a smooth support. And here you are going to have BY, BX. Why? Because this is what? This is a pin or a hinge. A pin or a hinge is going to be what? X and Y. So you have to know the type of support. That is why I introduced this. I started this so that you can go and revise this. So now, so when you have the forces, look at it. Again, you can either decide to start from the moment, or you find the summation of X. So if I want to find the summation of f of X, so if you go to the next, this thing, I start with what? I start with the moment. So where will I take the moment? So don't go to the next page. Where will I take the moment?
B, sir.
At B, because there are what? More forces here to cancel here. So if I take here, I'm going to take this, I'm going to take this, take this, take this. 5. But if I take it here, I'm only going to be 1, 2, 3. So that is why knowing where to take the moment. So if we're taking the moment here, so these are the only 3 forces we have. This guy is going to be 0 because it is passing through the point. So what's going to be what? AY multiplied by what? Multiplied by 2 plus 3 plus 2. Right? 2 plus, because the distance from here to here is what? Is 7. So it's going to be AY multiplied by 7. So let's check. As you can see, taking moments about, so in their own case, they take moments about A. They take moments about A, which is, they are going to have 1, 2, 3, 4 in the equation. Sorry. 1, 2, 3, 4. 1, 2, 3, 4. Why?
Doctor, this shot is wrong, I think.
Yeah, I think there is
Yeah, you have
for another question, the answer.
yes. This
Grigori,
question is
are you
belong
sure?
to another question.
This solution belongs to another question figure.
To another question, yes. It is in the main slide in the classroom.
So how did I? The figure here, let me see. Okay, 54, right? And this one is showing what?
Another question.
Okay, but in the slide, in the work example in the class, it's right?
Yes, in the class, yes.
Okay. Okay. Should I let me bring it in so that those people who did not catch it will be able to understand it? Let me just give me 2 minutes to bring it. Just stop sharing. Right now.
Yes.
Okay. So as I was saying, so I went for the correction. So what we do, so as I said, you can either start with what? With writing the equation of the forces or the equation of what? The equation of the moment. So so if we start with, for example, we want to start with the equation of moment. So all of this will be cancelled. So we're going to have AY. So AY is going to be what? Multiplied by what? Multiplied by 7. So as we can see here, if we take the moment at B, initially what they do is they can find BX. You can find BX directly. How? Because this is the only force in what? This is the only force in what? In the X direction. And this is the only force also in the X direction opposite to it. So it means that these guys and these guys are equal. That is why they are in equilibrium. So 600 cos 45 minus Bx is going to be 0. So look at it, 600 cos 45 minus Bx equals to 0. So that's why Bx equals to 424. Now, also, for AY, we can find, if we know AY, and we already know this guy, the only force we don't know here is we can also find it in the direction of AY. We're going to have, this guy is going to be plus, right? This one is going to be minus. This one is going to be minus 100 Newton. It's going to be minus. And what? BY is going to be what? Plus or minus. It's going to be plus because it is in the same direction with AY. It's in the direction of our orientation. So our AY here and our AX here. So look at our AY. So if you do that, so now after they do, you can either come here. So, but when you come here, you are going to have two unknowns in the equation. So you have to come back here and solve this one. That's why they decided to take what? To take moment about B in order to find AY. So when you find moment, so which means you can take moment twice. So when you take moment here, when you take moment at what? At B, we say 100 Newton multiplied by 2. Let's go back and see. 100 Newton multiplied by what? Multiplied by 2. The distance from here to here. Because they are taking moment about B, right? They are taking moment about B. Look at it. That is why the subscript B is written here. So when it is written like this, it means that this is the point where we are taking the moment. The small letter here means this is where. So look at here. It means that we're taking moment at A. So 100 Newton multiplied by 2 is going to be what? So is it going to be clockwise or anti-clockwise?
Anti-clockwise.
Now?
Anti-clockwise.
Yeah. Please, if you want to ask questions, just put up raise your hands. So let me ask, so the question I'm asking, so this 100 Newton, if you are taking moment about it, is it going to be anti-clockwise or clockwise?
Anti-clockwise.
Anti-clockwise.
Clockwise.
Yeah,
So
it
that
will
is why,
be-
so plus, because that's our convention. You can decide to take your anti-clockwise to be negative, then you have to maintain that consistency. If your anti-clockwise is negative, then your clockwise become positive. So in our lesson, we are taking the anti-clockwise to be negative, to be positive, so our clockwise become negative. You can decide to switch them. There is no issue. You are still going to get the same answer as long as it is moment. Is it clear? So then we're going to take what? 60 sine 45 is going to be what? It's also going to be anti-clockwise. Multiply by what? We're going to multiply it by 5. Look at it. It's plus anti-clockwise. The other force there is what? Is this guy itself, which is going to be AY multiply by what? Multiply by 7. It's going to be multiplied by 7. So look at it. AY multiplied by 7. So all is equals to 0. So we can find AY. So when you find AY, then we can do the summation of AY to get BY. So alternatively, this is an alternative just to confirm that you can also take moment at A to have what? To have the same answer. So which means you can use the summation of force to get your answer, or you can use the summation of moment to get your answer. This is what this means. Yes, any question? Who want to ask question?
I have question, teacher.
Yeah.
Doctor, regarding to the x-axis for the cosine, can you go to the picture?
This guy?
But can you back? Yeah. Regarding to the 600 Newton, 45 degree, it's going right for regarding to the x-axis. How it's negative for the?
Which one?
See, 600.
You mean here, right?
Yes.
You mean here, right?
Yes, here exactly. 600 cosine 45. It's become negative.
It is not the force that is negative. It is the moment. You see, when
it's for the moment. Yes.
Yes.
I don't know if it's counterclockwise or it's clockwise.
It is counterclockwise, right? When you take moment about B, it's counterclockwise, right?
For the y-axis, I can know it's easy actually, but for the x-axis, it's not that easy.
Which one?
For the
here we did not take any moment about this. This one did not take. We did not take moment of this.
They took it and multiply it by 0.2.
Oh, okay. Yes, you are right.
Yes.
You are right. We are considering what? We are considering the thickness of the beam. So here, if you are taking yes, good for that observation.
Yes.
Sometimes you can be asked to neglect the thickness of the beam. Here, if we neglect the thickness of the beam, then we assume that this force is passing through
0
directly.
Yeah.
Yes,
We assume it is 0, but here it's not neglected.
It's not negligible. So there is a thickness. So we're going to use this distance. Look at here. When you take a moment about this here, this force is trying to rotate it this way. Can you see my arrow?
I see your arrow actually.
Can you see the way my cursor is moving?
Yeah, but you your arrow is clockwise. It should be negative, yes. But how can I know it's going like that? It's x-axis. For y-axis, I can know easy. But for x-axis, it's not that easy. You know my question.
So what you need to do?
You understand my question?
Let me do something. So what we need to do is to.
It is if it's above the x-axis, it's going to be the right. If it's below the x-axis, it will be the left.
It depends, because the direction of this arrow can also change. You know that. So
yes,
if the direction of this arrow change now, it becomes clockwise.
Yeah, if it's changed, then the opposite side.
The opposite, yes. So
if it's above the x-axis, it will be negative. Always.
If it is above the x-axis and you are taking what? Where are you taking the moment depends.
In the B.
So if it is in the B, then it's going to be clockwise, right?
Clockwise, because of above the x-axis.
X-axis. But if this arrow change and it is still above B, it's now going to
Okay.
be.
Sure,
It's going,
sure.
it's now going to be what? It's going to be anti-clockwise now.
Of course. Okay, of course. Yeah, I can use this as,
So you cannot say.
reference.
The point I'm trying to make is that you cannot say when it is always above. It depends on the direction of the arrow.
Sure.
So,
Okay.
for example, just wait. Let me do something. Assuming the first change like this, can you see the new arrow I draw? You can see the new arrow here, right? Let me make the arrow to be different format shape. Shape of line. So you can see the new arrow, right? Red.
Yes, clear, doctor.
So now, what will be this moment now? This moment
It will be positive.
It will be positive.
Yes.
So look, the arrow is still above the beam. So it depends on the direction of the force. It depends on the direction of the force and where you are taking the moment. But if I move the arrow down here, so what it become now?
It will be negative again. Yeah. Clear now.
It's clear, right?
Yeah, clear now. Thank you, doctor.
You're welcome. Okay. Yeah, because it is passing directly through here, through the point of support here, the point where you are taking the moment. You see, all these three forces are passing through there. So it is going to be zero. There is no distance between this force and this point. So what I'm trying to, for example, another this thing for that, this thing is this. Let us assume this arrow, this force is here. So what will be the moment now? The red arrow.
Zero.
What will be the
Zero. It will be zero.
Why? Because it is passing through the point where you are taking the moment. The line of action is passing through the point where you are taking the moment. So the same thing applies to this. It is passing through the point of your what? Of where you are taking the moment. You are taking the moment about here, so it's going to be zero. But if I'm taking moment about here, this guy is no longer zero. What will be zero if I'm taking moment about here? Do you understand my question? Hello?
Yes, doctor.
Are you all there?
Yeah.
Yes. If I'm, for example, if I'm taking the moment about this point now, what will become zero?
A.
Which A?
AY.
AY becomes zero. Good. AY becomes zero. If I'm taking moment here, AY becomes zero. So as you can see in their second example, you see when they take moment about what? About A, did you see AY here? You cannot find AY here because it is zero. But the 200 what? The 200 appear here now. So Omar, Otebi, you can see the 200 appear here now. Because they are taking moment at what? At A. Okay, good. So I wanted to spend 30 minutes on this revision. So I've spent only 40 minutes. I don't think I'm going to exceed 1 hour. So the other thing is that when you are asked to replace a system of forces and couple moments, simply what you are asked to do is that find the resultant moment and find the resultant force. That is all you are asked to do. When they say replace the force and couple system by a couple and force moment, what you are asked to do is to find the resultant force and the resultant moment. So here we have these forces. They are going to give you the point that where you're supposed to produce the moment is going to be given to you. So if you find summation of f of x here, the summation of f of x is going to be what? It's going to be, let's start from here, maybe. It's going to be 3 kilonewton costat, right? In this direction. Our direction, look at our direction, we already put our direction to be x here and y here. So this is going to be cos 30. So this guy is going to be what? Cos. It's also going to be cos, right? And it's going to be plus. But so if it is going to be, there is no angle here, so you have to use the figure that is given to you here. So since you are resolving along the horizontal axis, so it becomes 3 over 5. 3 over 5 for the x. So that's why 3 over 5 multiplied by 5 kilonewton. These are the only forces you can put that you can resolve into horizontal. This one is the f of x here is what? Is 0. Because this one is directly y. It's directly y. So that is why you don't find it here. So when you add the two of them together, you have 5.598 kilonewton. Now let's come to y. Y, this one will go up 3 kilonewton sine 30, right? So it's going to be plus. Here, it will be down, it's going to be minus. If it is down, then this is the axis you are resolving into. It becomes 4 over 5 multiplied by 5 kilonewton. Minus. This one is already in y, so minus. So you have this. Then you go and find the resultant of this, which is what? The square root of the square of the sum of the square. You square this one, add it together, and you take the square root. So, which is what is done here. This is what is done here. So I just bring so that we can have them on one page. So I bring what we did before here. So again, look at the direction of the arrow. This one is telling you that this is positive and this is the counter. The established y direction. Your established y direction is in this direction. Now the answer you are having is minus, so it means it is in this direction. So there is a reason for this, so that when you go to show your forces, so it will help you to know how to orientate, how to position what? The f of r, the resultant force. So now, so we have to find the angle. The angle is going to be what? Tan inverse of what? F of ry and all over f of rx. Ry over rx. So this gives us this, right? 650 all over 5.598. Is it clear?
Yes,
clear.
Okay, now you are asked to take moment about O. So the moment about O, you are to ask to take the moment about O. So let us look at the forces. The 3 kilonewton. Let me go back. The 3 kilonewton, so it's going to have what? It's going to have two components here, right? As shown here. This one has two components as shown here. So if we take moment about O, so this is going to be what? 3 kilonewton multiplied by what? 3 kilonewton sine 30 multiplied by 0.2, because the distance from here to here is 0.2. It is shown here. The distance, so the distance from here to here is 0.2 here. And what is going to be? Is this going to be anti-clockwise or clockwise?
Anti-clockwise.
Anti-clockwise. So it's going to be positive. Let's go and check. As you can see, 3 kilonewton sine 30 is multiplied by 0.2. Sorry. The next one is what? 3 kilonewton cos 30 multiplied by what? This distance, 0.1. This is clockwise. It's going to be negative, right? Negative. The same thing for the 3/5 force, the 5 kilonewton here, what is the distance from O? Is this guy. And it's going to what? It's going to be anti-clockwise, right? 0.1. So we're expecting this one to be 0.55 kilonewton to be positive. Look at it, it's positive. So the same thing you apply to the rest of the forces. And you have what? Your answer is going to be minus. If it is minus, it means that the moment is what? The resultant moment is what? Is clockwise. That's what it means. The resultant moment is clockwise. So now come and fix the force and the moment here. So if you want to fix the force, look at this guy was negative. So it should be what? So negative and this guy is positive. That should help you to decide which quadrant it should be in. So let me do something here quickly. You want to be here. So we assume that this is your quadrant. 1, 2, 3, 4. This guy is positive, right? This guy is positive. This guy is negative. This guy is negative. So if your f of x is positive, your f of x is positive, it should be here on this direction. And if your f of y is negative, it should be here. So it means that your resultant force is going to be here. That is why it is drawn like this. Your resultant is going to be here. Because this is positive, this is negative. And then the angle it makes with x-axis. It's always the angle it makes with the x-axis. That is why it is put here to be what? To be 49.3 degrees. Is it clear?
Yes, Doctor, clear.
Now the moment. So look at the moment, the way they put the moment. You have to show the moment also with arrow, showing that it is what? It is clockwise. That is why it is minus. The final answer is minus. That is why they put it this way. If it has been positive, they will put it this way. They will reverse the direction of what? Of the arrow. So the same thing with this. It's just the same thing for you to get more idea. So the same thing with this, you have to look at the forces. The f of x, the f of x is going to be 500 Newton multiplied by what? 3/5. Look at it. And then you see, in this particular question, nothing was done here. This one was not brought in. Why? Because this guy already cancelled this. This guy, the summation of this is 0. So that is why he did not find it in this equation. For f of y, you're only going to have 750 and what? And 500 multiplied by what? By 4/5. 4/5. So this one is going to be positive and this guy is going to be negative. And it's equals to 0. So, yeah, so it's supposed to be, excuse me. So if this is in equilibrium, so this guy minus this guy, so it's going to be so the total sum of the forces in the y is going to be what? It's going to be 350 Newton. Right? So here we're going to have what? We're going to have the magnitude. R of x, R of y, square, then, so 300, 350. Again, take the angle. The angle is 49.4, right? So look at how it is drawn. So this guy is what? This guy is positive, which is in this direction. And this guy is what? Is negative in this direction. Now look at the moment again. The moment is given this way. because it is what? The total moment is what? The total moment is negative. So which is what? If it is negative, then it is what? It is clockwise by our own convention. Is it clear? So here, centroid of basic shapes.
Doctor, one
The
question.
first thing you need to know is that these are the basic shapes, the areas, how to find the areas of these basic shapes. These are not complex shapes, so you are not expected, don't expect the equation for this, for the areas of these shapes. These are common shape. So then the centroid, when you say centroid means the position where you can balance the body. So if you have a uniform rectangle, this is where you can balance it. If you have a uniform triangle, this is where you can balance it. So where you can balance it is 1/3 from here, and it is 2/3 from here. The same thing, 2/3 from here, 1/3 from here. For a rectangle, it is half of the base and half of the height. So here, what this guy is giving you what? The coordinate of this point. These are the coordinates of this point. For circle, it is at the center, which is just the radius. For semicircle, you are going to have 4r/3 pi or 0.42244 r. 4/3 r over pi. So, or this one. And this is the area of the circle. Sometimes you have what? You have a shape that is what? That is composite. When you say composite, it means that one, two or more of this what? Of these shapes are joined together. So the method we normally use, we call it what? The composite method, where we divide the shapes into their basic shape. So for example, if I are giving this something like this, I can divide it into what? One rectangle or this way. The second rectangle or this way. And the third rectangle this way or this way. So we have decided to go this way, here and here. So I now have three basic shapes. 1, 2, and 3. Part 1 is this, part 2, 3. So what is the area of this? This is a issue. You know that this is a rectangle. It's going to be 50 multiplied by 20. That's why we have 1000. So if it is a rectangle, where will be the centroid? The centroid, look at where you orientate your x and y. So if my x and y is here, then my centroid is going to be what? It's going to be from here. The distance from here to here is what? Is 100, right? The distance from here to the edge of this triangle here is 100, right? But this triangle is just 50. From here to here is just 50. So I know that this guy is going to be from here to here is going to be 25. And from here to here is going to be 10. But I have to do my measurement from here. So I move 50, then plus what? Plus the 25. That is why the x is what? 75. Then I'll multiply this by this. The same thing, y, if I want to find the y coordinate, I have to move from here to here. So I'll move here 20 plus this is going to give me 100. This guy is just 10. So 100 plus 10 is going to give me 110. Then 50. So I'm going to have multiply again the area multiplied by the y bar. So it's going to give me this. The same thing for the second one, the same thing for the third one. Then when you do that, you add the a together, you add the a x prime together, you add the ay, so not prime, a bar, and then a y bar together to have this. For you to find the coordinate of where the centroid will lie is to divide this one by this one and divide this one by this one, which means the centroid of this guy is lying at a coordinate of what? 81 in the x and what? 50.7 in the y. Any question?
Doctor, I have one question.
Yeah.
You can see downstairs there. There's AI multiplied by XI over AI, right?
Yeah.
Yeah. Why AI doesn't go with the AI, the below AI?
Let me understand you properly. You mean here, right?
Yes, this AI. Why is not going
Okay.
down with the below AI?
This one?
Yes, this one.
No, you have to consider. So don't look at it individually. Consider this one together. What is the summation? What does this mean? This means summation of the area.
Yes, it is the area. Yeah, submission. Same the up one.
No, this one is not summation of area. This is a product. This is a product of area and this guy.
Only this one. Okay, clear.
This is summation of. So you cannot separate. That's why I say you should look it together. Don't separate this one Don't separate this one and this one. This is summation of area and. So
And
here
this.
we are saying I. So we mean that summation of what? The summation of the first one.
Okay.
This I can be 1, this I can be 2, this I can be 3.
Yeah.
So it means the summation of all of the what? All of the I. So
Okay.
here is what? Is the product of this, which is this.
Yeah, clear.
We add them together to get this.
Yeah, no, clear now. Thank you.
The same thing here, right? So the same thing here. So this is one of the practice questions I put in the slide. So if you have worked it out, so you should be able to get the same thing. Sometimes when you are given a shape, you have to look at the shape whether if it has what? An axis of symmetry. An axis of symmetry is just a line that can divide the shape into 2 equal parts. Look at here, there is no way we can divide this guy into 2 equal parts. If we divide it here, this guy is longer than this. When you say axis of symmetry is a mirror, it's like the mirror, one half is a mirror of the other. So look at here, we can actually draw a line here, right? To divide this shape into 2 equal parts. So let me do, and then you can see what we mean by axis of symmetry. Insert shape. The red one and the what? And the, I don't know whether it is blue or the purple line. So if you see the red lines, it divides this shape into, when you divide into this shape into 2 equal parts, right? This is what we call axis of symmetry. We cannot call this one axis of symmetry because the part of the shape that is here is not similar to the part of the shape that is here. But this one, the part of the shape that is here on the right is similar to the part of the shape on the left. So this one becomes the axis of symmetry. So when you see a shape like this, you can just draw an axis of symmetry, and then that's actually reduce the numbers of your table. It reduces your work. So here, then I can find my what? I can find my centroid, the position of my centroid only along this axis. No need for this again. Because this is because my centroid is going to lie around this. So let us divide the shape. So I'm going to remove this. So how many shapes do we have here? 3 shapes. This is what, so I decided to put everything very clear. Horizontal triangle, this one. The vertical triangle, this one. And then what? The circle. What is the area of a triangle? The area of a triangle is 150 times 150 multiplied by 15. I have this. The same thing for here. 150 multiplied by 15. Area of a circle is pi r squared. Let's give me this. Now, if it is a rectangle, where will it lie? It's going to be somewhere here, which is going to be 7 point. So I am no longer finding from here because this is I already have an axis of symmetry. So I'm just going to find along this point. So this is going to be 7.5. If I'm what? If I put my XY here, assuming I put my what? I put my XY here. I can decide to put my XY anywhere. I can put it somewhere here. I can put it here. But you have to be consistent when you are taking what? When you are taking your distance. So I put it here. So I'm going to have from here to here is what? 7.5. That's why I have 7.5. I know this guy is going to be somewhere here. So which is going to be from here to here is what? 75, but I have to add this 15 also because I'm starting from here. I have to have 15 plus 75. That's why I have 90. The same thing, I know this guy is here, but I have this, since I'm coming from up from here, I have to add this, and then have half of this. That's why I have 15 plus 150 plus this. So I have to multiply this by this. So which is what I did here, to have this, have this, have this, have this. Then you use the equation. The summation of what? A y bar divided by the summation of A. Is it clear?
Yes, doctor. Just for confirmation, did we raise the centroid to the top of this picture or this drawing?
Did you what?
Did we raise the centroid, the axis to the top? Why we consider it from the top? Not from the centroid, that drawing. Yeah, it's my decision, right?
You can decide to take it from here.
Oh, okay. It's based on my decision.
You can decide to take it from here.
Okay. I can choose the easier for me.
Yes. So if I take it from here, it's still going to give me the same answer. You can go and try it. From here to here is going to be, this guy now is going to be 50. It's no longer going to be 215 again.
Yeah, so it sounds good. Okay,
so thank you. This guy now is going to be what? It's going to be 100 plus 75. This guy is now going to be 175. It's not going to be 90 again. This guy now is going to be 100 plus 150 plus 7.5. You get it?
But the answer will be the same, right, doctor?
The answer will be the same. The answer is going to be the same. Just check it. So you are going to divide. You are going to divide here. You are going to, from here to here now is going to be what? It's going to be 100. So if I want to find that of the cycle now is no longer going to be 215. It's going to be 50. Just 50. So then if I want to find for this rectangle, the vertical rectangle now is now going to be 100 plus 75. So plus 75. It's going to be 175 now, not 90. This one now is going to be what? It's going to be 100 plus 150, which is 250, plus 7.5, which is 257.5. This guy is not going to be 7.5 again. So when I divide it by this, I'm going to have the distance from where? Because I'm measuring from here, I'm going to have the distance from here to here. But since I'm asked to find that the question is indicating that it should be, I am calculating from here to here, then what I will do, I will minus this guy from the whole of this length. It's going to give me the same answer, 154.5 mm. You can try it. So, equivalent point load. So, sometimes this is what we call uniformly distributed load, right? So, sometimes you can. So, for you to solve problem involving this, usually we have to convert what? We have to convert the load into a point load, or what somebody told us the other time, concentrated load. So, it is like the application of what? Of the method of determining the centroid by breaking it into the basic shape. So if I break this guy into the basic shape now, I'm going to have rectangle and triangle. Then this guy, if I want to find the point load is only going to be the area of the shape it formed. So this is the area of this shape, 8 kilonewton. This is going to be the area of what? 1 over 2 multiplied by 1.5 multiplied by 6. 4.5 kilonewton. Now, where will they lie? I know for a rectangle, it should be at what? At the center of the rectangle. I know for a triangle, it's going to lie what? 1 over 3 from here. From here to here is going to be 1 over 3. From here to here is going to be 2 over 3. So, the point load, the resultant point load of this, where will it lie? It's going to lie between these two guys. So, I decided to put it here. Then I'll apply the principle of moment to find what will be the distance of this. So if I apply this principle of moment, this guy is going to be what? 12.5 multiplied by x. This is the distance I'm looking for. The distance from here to here, x. Or let me insert something. Given to you. So find the reaction at what? At the support. So which is the part of what? Equation of what? Equilibrium, or the equilibrium of rigid bodies. So I'm going to find here, I know the type of joint here is what? It's a smooth joint. So I'm going to have A prime, AY, subscript Y, and this one is going to be what? CY and CX. Because this one is a pin support. So when I apply the equation of equilibrium, so I'm going to have AY to be 600 Newton and then CY to be 200 Newton. And CX is clear. CX is 600 Newton. Because this is the force, this is the only force in X, and this is another force in X. So I'll start by what? I'll start with joint A.
We assume direction, Doctor, here. In this question, we assume direction.
Direction in, like how? Can you
in joint A, in the figure below.
Okay. Yeah.
Yeah, the arrow of FAB, it is downward.
Of AY, arrow of SAB, where, let me see, where do you see SAB?
No,
arrow of SAB?
In the figure below, Doctor.
You mean here? Okay,
yes,
okay.
Exactly. FAB.
Yeah. FAB.
Yeah, arrow
okay.
is downward, right?
Yeah. So you want to know? Okay, yeah.
Yes.
Yeah. What we do? What we normally do? See, if you know the known force, this three arrow is representing what? The three arrow is representing. This guy is representing this one, right? This one is representing this one, and this one is representing this one. So the common sense we use here, we use common sense. We said if this guy is going to be what? AY, the forces that will make it to be equilibrium should be pointing down. That is why we take this, we assume this direction. Did you get my point?
Yes, Doctor, but it is it's clear if it's align with the same 600 Newton.
600 Newton. Where is 600 Newton?
But it is
no, because 600 is a different joint. This is a different joint. We are considering only this joint.
Yeah, I'm talking about this one.
Okay. Do we have 600 Newton here?
Yeah, if it's exactly on y-axis, then it makes sense. But in this situation, it could be because based on this figure, we can know it is tension or compression.
Yeah, you see, the basic thing is just choose. You can choose it. You can choose it to be tension, no problem. You can choose it to be tension. Choose all the distinct to be tension. Then, if your answer is positive, then it means the direction you choose is right. But if it is negative, then it means that it should have been the other direction.
So better we assume all the joint reactions.
If you assume all the joint, yeah, even if you are going to assume all the joint, you have to apply logic. You apply logic. So the logic I'm applying here is that since I know that this force is 600 Newton, any force that is going to be what? That is going to be to counter it to be in equilibrium should be pointing downward. I cannot have two forces. I cannot have two forces pointing in the same direction to be in equilibrium. No, unless they are both of the forces are zero. I cannot have two forces pointing the same direction, only two forces. If I have only two forces on a body, if both of them are pointing to the same direction, they cannot be what? They cannot be in equilibrium. So this is the logic you have to apply here. That, okay, since this one is going up, any force that is going to make it to be in equilibrium should be coming down.
Yeah, I do agree with you. I do agree with you, doctor. But if you compare,
so let me finish. If you draw this arrow to be in this direction, by the time you do this f of AB is going to be what? It's going to be negative. It doesn't mean that your answer is not going to be right. It's going to be negative. Then you have to change your assumption now. That, oh, this is not what? This is not compression, this is tension. Or this is not tension, this is compression. Yeah, you can make your point now.
Yeah, by what you said, logic, doctor, below, it is giving 600 Newton, while the B joint applying 400.
B joint? No, don't go to
from
B.
below,
Forget
it
about
is higher than the 400.
No. Don't go to B. That is why we call joint method. Joint by joint method. You consider only one joint at a point. Don't look at what is happening at B. Don't look at what is happening at D. Don't look at what is happening at C. Look only at what's happening at A.
Okay, makes sense.
Yeah, that is why it is called joint by joint method.
Okay,
so
you.
When you choose a joint, you concentrate on that joint. You don't care what is happening in other joints. You get the point?
Yes, doctor, thank you. It's clear now.
Yeah. So then, when we do that, so we said it. So the assumption is that each joint is in what? Is in equilibrium. Since there is no movement, so it's in equilibrium. So F of Y is going to be 600 Newton. F of AB, what? Is going to be 4 over 5. Minus 4 over 5 is equals to 0. Then from there, F of AB is 570 Newton. So compression, you see, it is what? If you choose your arrow and it is pointing to the joint, it's a compression. If it is moving away from the joint, it's a tension. If you have made the direction of this to be in this direction, you still get 750, but the 750 now will be negative. So if you are considering a joint and your arrow is pointing outward, and the arrow pointing outward means it's a tension. These two guys are compression. This guy is compression because they are pointing what? They are pointing to the joint. If it is pointing away from the joint, it is a tension. Is it clear now?
Yes, doctor. Thank you.
Okay. So now I move to what? I move to D, because by solving this, I already know this. I know this. I can also decide to move to B, because by solving this, I know this. I know this. But here I have two unknowns, right? I have two unknowns. Here I know this already. I know this. This guy also. So I can either move here or move here. So when you are taking a member, the member should have just two unknown. If you have a member that has more than two unknown, don't go to that joint. If you have a joint that has more than two unknown, don't go to that joint. Choose a joint that has only two unknown and one known, or more than one known. So if we come to what? If we go to D now, so sorry, if we go to D, so look at D. By the time we cut D, so we cut D, we take D here. So this guy is already pointing to this. So when we solve this, what was our AD? Our AD was 450 Newton tension. So look at it. Here, it is also what? It is also moving away from here. At D, it is also moving away because it is tension. When a force is in tension in one joint, when it comes to the other joint, it's also going to be tension. So look at this one. We're assuming it to be compression because the common sense is that for a force that will make this one to be in equilibrium, it should be in this direction. So we already have 600 Newton here. We have F of DC here. So we can apply also our summation of F of X, which is going to be 600 Newton FDB multiplied by what? Multiplied by 3/5. And then 600 Newton and then minus 450. Because minus 450 is going in this direction. Then from here we can get FDB to be what? To be minus. So FDB is actually what? It's actually tension. We assume it here to be what? To be compression. While we are doing the what? We are doing the while we are solving this joint. But if the answer become negative, it means that the direction we choose should have been the opposite. So it means that FDB is tension. Then F of Y. So F of Y, if we are still going to maintain this, then you have to allow this. You have to allow this. So you use it to solve your this. That is why FDB, they still maintain what? Minus here. Your answer is going to be 200 Newton compression. If we have changed this sign, if we bring this one as 250 here, this guy become what? Become minus. Then we have to assume it to be the other way. Then you go to joint C. So at joint C, you almost already know everything. Sorry, if you come to joint C, so what happened? You know this already, right? You solved this already. You know this already. So at joint C, sorry, my cursor is not. At joint C, so we already know this. You already know this. You already know this. So joint C is just a formality that they did there. So from here, I can know this guy balances. This guy is going to be equal to this. Is it clear? So when you are doing what, sometimes we also have to look at the truss and see if it is what, if it has any symmetry. So if you can draw a line that will make the truss to be what? To be the same on the left and on the right. In terms of what? In terms of shape and in terms of loading. Both shape and loading. So as you can see here, if you see this truss, look at this guy, it's reflected here. Look at this guy, it's reflected here. If you draw a line here, this guy is reflected here. And the angle also, the loading also, this joint that's similar to this joint is 3 kilonewton. So instead of solving the whole of this, we can solve half of this, and then we'll say whatever force we have here is the force we have here. Whatever force we have here is the same thing we have here. Whatever we have here is the same we have here. Whatever we have here is the same we have here. And what it means. So applying what? Again, before you go to calculate, you have to find what? The reaction if they are not given. Here they are already given. You are told that AY is 4 kilonewton, DY is 4 kilonewton. Then AX 0 and then is it clear? So now when you can, then you can start with what? With any joint where you have 2 unknowns or less than 2 unknowns. So if we start at joint what? At joint A, this is joint A, we know this, so we have 2 unknowns here. So if you draw this joint, this is going to be this guy, this guy f of ag and f of what? X. So now f of y is going to be 4 kilonewton, then this one sine 30 is equals to 0. So ag is 8 kilonewton. Then AB is going to be this guy, right? This is going to be cos 30, f of AG cos 30, which we already obtained as 8 kilonewton. FAB is equals to 0. So since our answers are what? Our answers are positive. It means the direction we choose is right. F of AG, we choose it to be in compression. It's compressing what? It's pointing to the, if it is pointing to the joint, it is what? It is, we assume it to be compression. So this one now is like, it's a compression. This is the tension here. So when we solve our equation and all our equations are positive, it means the direction we choose is right. So when we know this and we know this, we have a force here that we know. We already know this. So what do? We move to this joint. Why don't we move here? We don't move here because we have 3 unknown here. 1, 2, 3. 1, 2. 1, 2, 3 is unknown. So we come here. So the same thing, apply your equations of equilibrium. But look at here, what they did is that sometimes it is easier for you to orientate, especially when you have a straight member like this, and then another member come to join it. Instead of you to align your x of x axis on what? To maintain this, you make it along it. You make it along the what? Along the member itself. So that is what they did here. So they put what? The x here, and then the y to be somewhere here. Then you do the f of y and the f of x, you also get equal to 0. Then you get your answer. So when you know this, by the time you solve here, you will know this and you know this. I already know this, so I can move to B.
I have a question, Doctor, for this one. For
Yeah.
G-joint. G-joint, Doctor, for the 3K kilonewton, why do we not separate it into 2 components?
To what? So the 3 what? The 3 kilonewton?
Yeah, 3 kilonewton.
It is. Look at it here. Look at it here.
But
it was 3 cos 30 here, and it was 3 sin 30 here.
Wouldn't affect the 8 kilonewton?
The 8 kilonewton?
Yes.
No, it will not. No, because that is why, in the equation, that is why 8 kilonewton is here. Look at it. So if we are solving in what? This is now our x, right?
Yes.
This is now our x. So let's solve in x. S is going to be 8 kilonewton, which is this. This guy is going to be what? 3x sine, which is this guy, right?
Yes.
This guy, FGF, which what? FGF is what we are going to look for. So minus is going to be minus because it's in the opposite x direction. Yeah. FGB here is what? It's 60. So it means that here is 30. So if we take it here, it's going to be cos 60 minus again, because this is our direction of our x. So, but we already find what? FGB here. So that's why they bring the 3 kilonewton here. Okay. So by the time you solve it, you have your FGF.
Yeah, clear. Thank you.
So you do the same thing for what? So you go to joint B. You go to joint B, then you get your answer also. Because by the time you solve this, you know this now, you know this now. So you have only 2 unknowns here. So you have only two unknowns here. So you can solve for the two unknowns. Then after that, you move here. By the time you solve here, you know here, because when you solve here, we already know here, right? So we know here. So we're only going to solve for what? By the time we solve for this, we know this, right? We know this. Then automatically we don't need to solve for anyone here again, because this guy is equal to this. This guy is equal to this. This guy is equal to this, and this guy is equal to this. That's what happened here. Did you get the point?
But doctor, how to identify if it is compression or tension?
That is what I'm saying. If you draw your arrow to be pointing to the joint, that is compression. If you draw your arrow to be pointing away from the joint, that is tension.
But I can draw the arrow wherever I want.
Yes, this is the same thing. I have made this point several times. Draw it whatever you want. Your answer will now tell you whether it is compression or tension. If you draw it anyhow you want, if your answer is minus, it means that the original direction you choose is wrong. It's supposed to be opposite.
Okay. Okay, got it.
Draw your arrow. The basic assumption is that consider everything to be tension. Consider everything to be tension. So if you solve it and your answer is negative, it means that one you choose to be tension is what? It's actually compression.
Okay.
But if your answer remains positive, it means that the direction you choose is right. That is why in this example, look at here. Where's my? Look at here. When they solve this one is what? It's minus.
Minus 250.
Where is FDB?
Compression.
In this assumption, what is this? Is this compression or tension?
Compression.
Compression, but look at the answer.
Yeah, because of the sign, okay.
Yes, because of we got negative. When you have negative for your answer, then it means your direction, the original direction. So here, you can choose direction. It doesn't matter. Just choose any direction that's convenient for you. But your answer now will now tell you whether it is tension or compression.
Mm-hmm. Okay.
Is it important that exam I put is it tension or compression?
Now?
Is it important to put tension or compression?
Not only important, compulsory. Farid. It's Farid. Can I go on?
Yes, Dr. Mohammed, yes.
So look at, I have this guy again. I decided to introduce this again to demonstrate what? The symmetry. So I can draw a line here to be what? To be symmetry in shape. But for this guy to be symmetry, completely symmetry, this force must be what? Must be zero, because there is no force here. If this guy is not zero, for this guy to be symmetry, I have to apply the same force. For example, if P2 is 5, for it to be symmetry, I have to apply 5 here also. So symmetry means both in loading and what? And in shape. Not only in shape. It's both loading and shape. So if we don't know, then if here is 0, then we have to. So we can start from here. So which means when we have this, we need to solve only half of this or half of this, any one of this. We don't need to go for. So look at the question. Determine the force in each member of the truss and state if the members are in tension or compression. Set P1 to be what? This, and P2 to be 0. Because they want to maintain what? They want to maintain symmetry here. That is why they put P2. That's why P2 is 0. If P2 is not 0, then this is no longer symmetry. You have to solve for all the joints. Is it clear?
Yes, Doctor, clear.
Yes. So then the same thing, f of y is 0, then FBG is 0. We start from joint B. So the same thing, after I solve that, I will know this, then I can come and do joint G, because I already know this. I already know FBG. Then I have only 2 unknowns here. So I can also solve this. Then once I know this, I already know this. So I already know this. No need to come here again. I go to C. So I know this. Then I can find I already know P. So you're going to see today that this is equal to this. This is equal to this. AB is equal to CD. AB is equal to AB is equal to CD is equal to DG. Based on this on the solution here. BC is equal to CD. BC is equal to CD. Because of symmetry. AB is equal to DE. No, there is no DG. It's DE. This guy is D. There is no DG. This guy is DE. AB is equal to DE. So, any question? Shear force and bending moment diagram. So, again, you have to find reaction. This is a rigid body. It's like, so the rigid body, you find the reaction by taking moment about any point that is convenient for you. For example, the bending moment here is what? 24 multiplied, because you are given this question, you don't know the reactions here. So, then, for example, when you start this question, you can decide to put your arrow here. Your arrow can be in this direction. It doesn't matter. It means that when you solve this, you are going to have minus 75 kilonewton. That will tell you now, okay, change the direction of your arrow. So when you are finding the reaction, you can put your arrow in any direction. Then your answer will tell you, okay, this reaction is supposed to point to this direction.
Sorry, doctor, I didn't get it. How the 7.5 going down while the 31.5 going up? Why it looks same in the up? Yeah, in the figure.
When you
Okay,
add 24
above.
and 7, hold on. 24 plus 7.5 is going to be what?
31.5.
Yeah, so because this is in equilibrium, so the 31.5 here should go.
Oh, that's the reason.
Yes.
Okay.
To balance it.
Okay, clear.
So when you do that, so then you use the procedure for what? For drawing what? The moment diagram by cutting. So you start by cutting the beam. So I'll cut the beam here. Before I go to a load, I cut the beam somewhere here. So if you go to the slide, that is the method we use. So when I cut the beam, then I try to find what? The shear force equation and the bending moment equation. But the simplest thing is that when you have a point load is the simplest thing. The bending, the shear force is always what? It's always constant along the beam. It's constant along the beam. So, and the shear force is equivalent to what? It's equivalent to what? The load here. So that is why when you draw this, so if you have a point load that's pointing to this, the shear force diagram is just this length, and then it continues to come until it meets another load. This one, the shear force is supposed to be up. It's going to be up. The shear force is going to be up to go like this. So because there's already a shear force of down that is going like this, so you have to multiply this 31 minus 24. This 31.5 to cancel the 24, remaining 7.5. The 7.5 will take it here directly to here because there is no any other load here. If there is any other load here and the load is pointing down, then at this point, this guy will change direction again. I'll start coming like this. But if you have a load here and the load is pointing up, so this guy will go up again and then it comes to end. This is the logic for drawing the bending moment, the shear force diagram for a beam.
Doctor, if I draw directly, is it okay?
No?
Sometimes some questions I can draw directly, like this question.
Like this one. Like this one, once you find the reaction, you can draw directly.
Yeah, can I? Or you will text mark?
Maybe if you say I should deduct mark, I will deduct mark. But so drawing directly has, for example, if I have another point load here, let me insert. If I have another point load here, assuming we have another load here. So what will happen when I reach here? When I reach here, my bending moment diagram will become what? My shear force diagram will go up. Then it will what? Then it will come down. If there is another load here, this become my bending moment, this become my shear force diagram. So whenever we meet a load, if the load that is going meet another load and the load is pointing in the same direction, then the direction will continue and it will increase. But if this arrow had been like this, maybe the load we met here was, if the load was like this, what will happen? This guy will change direction again. This guy will change direction again. This guy. And then this become my bending moment. Shear force diagram. Why is this one smaller? Initially, I draw it bigger here. It was bigger here because this one will add to it. But it was smaller here because this guy, you have to minus this guy from what you have here to continue like this. Especially if the force here is bigger than this.
Doctor, so at the end it has to come back to the beam, huh?
Yes, because we are drawing along the beam. Yes, it come back to the beam.
Okay.
From one end to another.
Doctor, do we know how long it goes up and down?
Yeah, depending. That's what I said. If the arrow, you see, look at this. Your shear force diagram. Look at your force. Your force is pointing down, right?
Yes, and 24.
So you start from here. So your shear force diagram should point down.
Yeah, but for how long?
No, for this length. For how long? It will come like this. You mean the length here or here? When you mean how long, is it this way or this way?
No, up and down, doctor.
Up and down. This guy will be equal to the value of the force here. Look at it, minus 24. Can you see?
Yes.
It will come here minus 24. For example, if we are drawing to a scale, so you have to measure from here to here to be minus 24 because this guy is pointing down. It will come here. How long will it come here? It will continue to come here until it meets another what? It meets another load.
Yes.
When it meets another load, if the load is bigger than what? The load that you are coming from, then you have to subtract this one from this guy. And if the load is in opposite direction, then when you subtract this one from this one, you now have 7.5 kilonewton. It continues to go again. It goes again. There is no load again. So it will go to the end of the beam. But if you meet a load, like in this one now, assuming we meet a load, and this load is what? Assuming this load is, let me put something here. Let me say 50 kilonewton. Sorry.
Now subtract from 7.5.
Yes, from 7.5 now it will now be going down. So here now what I'm going to have 42.5, right? I'm going to have 42.5 now. So I'll draw from here 42.5 to be greater than 24. So so it will come down here. Then it will be going again. Sorry. But if it was up, let me make this one to be what? Let me make this one to be 10. So if this one is 10, what will happen? This guy become what? 2.5, right? Which is something like this. It become 2.5 to go like this. Smaller than 24. But what if this was like this? What will happen? This one becomes 17 point from here. When I reach here, I have to increase this one by 10. It becomes 17.5. Then I'll come here, come back to the beam. Is it clear?
Yeah, but start counting, Doctor, from the x-axis or from the line that you draw?
No, from the x-axis. We are moving like
From
this.
x-axis.
We are moving in the direction of the x-axis.
The total will be 17.5 from x-axis.
It will be what? 70?
17.5 from x-axis.
Yes, from the beam.
Okay.
From the beam, when you go up, it will become 17.5, right?
No.
So it means when you get to this point, this guy now become like this. This guy, if it was pointing in this, so it becomes like this. It becomes like this. Then so the bending moment, the shear force diagram becomes like this.
Doctor, it means to check our answers. If we calculate the area below and subtract from the above, it will be 0, right?
Yes, exactly.
Yeah.
That is just the point. The area below and above should be 0, should be the same. Look at here. What is the area here? The area here is going to be what? 24 multiplied by 250. The area here, right?
Yes.
It's going to be 24 multiplied by what? 250. What does it give you? Maybe somebody can check to verify that. In this calculator I'm holding.
$6,000.
Now is what?
6,000.
Okay, multiply 7.5 multiplied by 800.
Yeah, 6,000.
That settled the matter, right?
Yes, exactly. Thank you.
Okay. Thank you for bringing that observation. So when you have the area above the beam and the area below the beam should be equal.
Doctor, what about the moment of the lower picture?
So now we go to the bending moment. When you have a point load like this, your bending moment is going to be a linear equation. That is why somebody who say, I can just draw, it might be possible for you what? It might be possible for you in shear force diagram, but it's not going to be easy for you in bending moment. In bending moment, you have to find the equation. So your equation is going to be a straight line equation for a point load. So that is why we have this. So from here to here is going to be Px, which is going to be 250 multiplied by the load that you have. So the load that you have multiplied by this distance will give you the bending moment. Because it's a linear, it's going to be a function of x. The bending moment is a function of x. So that is why it is in this direction. That is why it is this shape. When you get to a load whenever a bending moment is coming and then it gets to a load, so it has to change direction. That is why from here it goes like this again, because from here the equation is PL minus X. But from here is Px. From here to here is Px. From here to here is PL minus X. So just check the slide and see how that was worked in the first example for bending shear force diagram. I can go and bring bending moment and shear force diagram. What was that lecture, sir? Lecture bending moment and shear force diagram. Okay. Let me go here. Just hold on, let me. Yeah, look at here. Bending moment and shear force diagram. You see, look at here. So when you want to write the equation, the first thing is to cut the beam before you get to a load. So that's what was done here. So they cut the beam before B. Then when you cut it before, your equation is going to be in X. So this is a linear equation. When you have an equation like this, 2.5x is a linear equation. The unknown, you have one variable that the degree is 1. So then from here to here, if I want to find the bending moment from here to here, is to substitute what will be the value of x from here to here. So for a linear equation, so when x is increasing, then the gradient of that equation should be increasing, because this equation is representing a gradient. It's representing a gradient. So then after you cut and you find the equation, then you have to cut again after the load. You have to cut after the load. Before you get to another load, you cut again. So this is what was done here. Look at after the load, it was cut. The beam was cut here again. Then the equation of this is going to be this guy. This is the equation of this. So that is why when they draw the bending moment diagram, from here to here, it was rising, because as I continue to increase the value of x, this guy is going to increase. And as I told you, when you get to a load, the direction of the bending moment will change. And this is going to be what? So using the second equation now from here, after the load, then it is going to go down. I think I finished. So any question?
Doctor, about the final exam, how many questions there will be?
How many questions? 5.
One of them is the theory or what?
Now?
one of them is theory question, or the 5 are calculation?
5 calculation for then one knowledge.
The knowledge question, will it be multiple choice or what?
It could be multiple choice, could be fill in the gap, it could be providing missing information.
Okay, thank you.
Doctor, for the calculation questions, if we studied this review properly, it will be in the same method?
Again?
For the calculation questions,
Okay.
if we study this review properly, it will be in the same way.
Yeah, the reviews I take it from your slide. So study the example or the examples in the slide. Because I cannot, if I bring all the example in the slide, it's like I'm repeating the whole this. So this is to help.
I'm not talking about the slides, Doctor. I'm talking about the tutorial.
That is what I'm saying, that the tutorial is from the slide.
Yeah, except but if I studied the tutorial, if I studied
studying the tutorial alone might not help you carry the whole. It will give you the concept. Yes, I will say I'm bringing this because this is how likely the questions will look like. So the tutorial, you can study the tutorial to guide you, but please, nobody should cram like it happened the other time. If you cram and the missing number is there, then you say you did not see it. So this should guide you. Also study the other examples in the slide. So I'll be leaving by 11. So we have 5 minutes. If you have any question within these 5 minutes, and if there is no question, we can call it a day. I plan to make it just 1 hour. Now we have spent.
Sorry, Doctor, and thank you actually for your work and teaching us. Okay, but I have one question regarding to the theory in the final exam tomorrow. Okay, what should we study about for the theory to prepare ourselves?
Yeah, all the topics I gave you, usually when we start a slide, we have what? We have main point. For example, look at when I start equilibrium. These are points that you should note. This is how to write the equation of equilibrium. The procedure for analysis, for example, these are points that you should know. If you come here, what type of reactions? If I have a reaction like this, so before I can solve any question like this, I have to know the type of reaction. So these are points we should know. For example, if I come here, like in here, if I come here, I should know where I should be line of symmetry. This is point I should know. If, for example, if I come here, what type of, for example, I should understand what type of loading is this. Is this a concentrated load? Is it a uniform load? So
we cannot see what you are showing to us.
Oh, sorry. It's like I'm no longer sharing.
No.
Let me go back.
You stop sharing, I think. You stop sharing. Just
okay.
A couple minutes ago.
Sorry, let me go back. How do I go? Okay, enter window. I'm back, right?
Yes, we can see now.
So, for example, when you start equivalent load, you should know what are the different type of load. This is a uniform distributed load. This is what? This is a concentrated load. So in each topic, there are some main points that you should know, which we normally put at the beginning of the slide or during explanation. And some of the thing is that it is not written. So when I come here, like here, when I'm talking
Doctor,
about
you stop the sharing now.
again.
We cannot see anything now.
What is wrong with this? Sorry, let me go back again.
Yeah.
Sharing entire this. Is back, right?
Yes, it's back.
Okay. So, like when you talk about trust analysis, what is trust? You should know what is trust. What are the members? What do we call members in the trust? Is it this guy or is it this guy? So, like here, when you talk about like in the bending moment and shear force diagram, I made a point the other time that like here, where you have the bending moment diagram, the maximum shear force is where you have the zero bending moment. And where you meet a point load, all of this could change, because I can give you a bending moment diagram like this. So I'll change all of this direction. So you should tell me which one is the right one. So I can give you a beam and say, okay, is this a symmetry or it is not symmetry? So these are some of the points. Usually in the slide, when we start a slide, we make some couple of definitions. We make some definitions and we make some points, especially in the analysis method. So as I said in this one, so if this is a type of beam, what type of beam is this? So this is a type of joint, what type of joint is this? So what do I need to do before I start doing analysis of a free body, analysis of equilibrium of rigid body? So does that answer the question?
Doctor, I have a question regarding this revision. In page number 10.
Page number 10. This is the last question because this is already 11 o'clock. Sorry, is it this one or this one?
Yes.
This one. Page number what?
Number 10.
When you read there, tell me. Is it here?
Okay, no, up, please. Up. It is for the moment. Yes. Just go below. Go down. Down.
Yeah.
Please. One page down. Yes.
Yeah.
For moment summation, Doctor.